Hi guys, welcome back to my channel. Today we're going to look at the concept of pointers, arrays, and strings at a fundamental level. And after that, we're going to hit straight to the task ahead of us, see how to utilize the solutions. All right, let's get started. Pointers. So what are pointers? I've got to realize that a lot of people got issues with pointers, thinking the concept is difficult and all that. I don't want to say it's difficult. It's not, all right? It's actually the same thing like variables, but the only difference is that a pointer points to the address of the variable. Okay? So let's just take, for instance, let me create a replit. Um I'm gonna call this pointers. Okay, so let me create a variable of an integer data type. I'm gonna call this int a. Let's say assuming it's equal to 5. All right. Now this is a normal variable, of course, which you can print f, and then so if you run this, of course, you have 5. Let's have a new line here, /n. If you run this, you would have 5 right here. Okay, but now a pointer, it's actually a variable declaration that points to the address of this value called a. All right, so having printed the 5, we can actually find out the address where this variable is stored in the memory. Now, what's an address? Let's test, for instance, if you've been using something like Microsoft Excel, you would realize that you have cells, right? And then you can choose to position any number there. Let's say you put 1 in a particular cell. And if you want to reference that cell, what will you do? You look for the cell address by calling A1, B2, or depending on the location of that cell, okay? And the same thing is applicable to a computer memory. It's just like that, but in a straight linear kind of line. You have a lot of memories allocation, let's say up to 10 gigabytes of your storage space, or 5 gigabytes, or whatever your storage space can take, or your RAM can take. Now, in all those large memory, when once you try to save, let's say int a, there should be a particular memory allocation allocated to this a, which will be 4 bytes, depending on the architecture of the system. So this 4 bytes is created in the memory of your computer. Then now, we want to know the address where this a is positioned in the memory. That's the need for pointers. Pointers directs you to the address where the variable is placed in the memory. So how do we define that? To define a pointer, of course, you need to provide the data type of the variable which you're going to point to. So we're going to have integer because a is of integer data type. And then asterisk signifies a pointer. I'm going to call it PTR, shortcut for pointer. You can just use anything. It doesn't really matter. Let's say number. Okay? Just like a variable name. So you can use anything. The only thing that differs between this and this is the pointer, is the asterisk. Okay? So int pointer number, then the number is going to point to the address of a. All right? That's how to declare a pointer. Okay? So if I want to print this pointer, I'm going to say print if percentage p. P stands for pointers. And then I'm going to pass in the number. Now, if I run this program, let's have a new line here. What you're going to see is the address of this value a. So let me run this. Now you can see 0x77 and the rest of them. This is actually the address that holds this value 5, okay, in the memory. Now note that this memory is the RAM. It's not actually your hard disk drive because it's not a file. It's in the RAM. And note that once your program runs for the first time, I run the program and then it's loaded to the memory. Now that program is no more on that memory. You only point the address. If I try to run it again, this address will change because it has to reassign a memory again for the value 5. So let's try that. If you notice, there is some change in what my memory address. This is 3C. Let's try it again. E3C. Let me run it again. You can see I have 32C. The more I keep running, it will continue changing the address. Okay, so that's it about pointers at a very basic level. There are more to this though. I'm gonna explain more as we progress in the program, but for now this is a basic level of pointers. Now someone can choose to ask me, what if I probably use P here instead of D, which is supposed to be a format specifier for integer data type. So if I choose to use P here, what you're going to see as a result is going to be a hexadecimal value, because the pointer prints the memory address in hexadecimal value. So if I use P here, what you're going to see is X times 5. Let's try that. You can see here X times 5 because the X stands for 0X stands for hexadecimal value. Now, if I change here to, let's say, 11, of course, we know that the hexadecimal value for 11 is B. If I run this program, you're going to see here 0 times B. That means an hexadecimal value for 11. Okay. So whatever I choose to use, let's say, D here, okay, you're still going to see the memory address, but what you're going to see would be in the decimal value, either signed or unsigned. If I run here, you can see 148761824, which is a decimal representation of that memory address in hexadecimal value. But it is preferable you use P because that is the allocated format specifier for a memory address. All right, so that's that about pointers. Now, I said earlier that since the address points to A, which has the value 11, you can at least, or you can know the value that is assigned to this variable using pointers. And what you do is to change this to D, because I'm trying to print the integer data type of A. So if I say D, I'm going to use my pointer here. I don't want to print the address, but I want to print the value that the A has. So if I say pointer to N, to num, and run the program, what I'm going to see is 11, which is the right value that's assigned to A. So that's how you can utilize pointers at this basic level. Okay, the next thing here is arrays. What is arrays? Arrays are simply values stored in a continuous memory location of the same data type. Let's say that I want to store a character. Let me just comment this out so we can talk about that now. Now let's say I want to write something like let's say a group of numbers. So I'm gonna say integer num. Okay, and then since it's an array, we're gonna open a square bracket, and inside the square bracket you will specify how many number of elements you need to pass. Let's say I want to pass something like 4 elements. I can put 4 right here, and then equal to, I'm gonna open a curly bracket, and then let's say I have 3, I have 7, I have 9, I have 5. That's complete 4 elements. And then I'm gonna terminate this line. Then probably I want to print, I can simply use either putchar or anything, putchar, and then num. Now, num, I'm gonna open a bracket, and what I'm gonna pass here is the index of the element I want to print. Let's say I want to print 7, so that's index 1, because the first value, a 3, is index 0. If I should pass 1 here and then run this code, I'm supposed to actually have 7 here, but remember that we are using putchar, which cannot actually be used to print a numeric value except you cast it to an ASCII code. So what I'm going to do is to add plus 0 here, and then try to print it again. You can see we have 7 because 7 is the first index of the array. So if I change it to, let's say 3, okay, that's supposed to be the last because it's 0, 1, 2, 3. That's supposed to be 5. So if I run here, I'm having 5 right here. That's just the basics of using an array, okay? And then I can choose to use printf. You can choose to use puts or any kind of function that writes to the standard output. Okay, and then the next one here was actually the strings. I think we've talked about strings. Strings is just a character data type. Let's say I want to character sorry, it's gonna be ja, and then let's say name, and then we have to open our bracket since it's an array. Of course, a character is actually, or a string, it's an array data type. So I'm gonna have something like, let's say, engine tech, and then I can put a numeric value 0, 1. Now anything right inside here is perceived as a string, as a character. It doesn't symbolize what it is, numbers, decimal, or symbols, something like these. It's still gonna be printed. Anything that is found inside this double quote is seen as a string. So if I want to print this, I can simply let me comment this out. Okay, I can simply say print f, and then what I'm trying to print is a string data type. That's why I'm using the s slash n new line, and then want to pass the name. All right, so if I should run this, okay, we need to terminate this line. Okay, all right, so this one again. You can see I have engine tech 0, 1 and then the percentage. So this is actually a string. Now, since a character data type, it's actually an array, so we can simply try to print this values, this character, one after the other. So I can say print c, percentage c, this time around, which is going to be character. And if I pass, let's say 4 here, it's gonna print 0, 1, 2, 3, 4. That's n. So if I run this, I'm supposed to have n on the screen, which you've seen here. So this is the application of strings, pointers, and arrays. And then you can choose to maybe print everything at the same time using putchar, depending on the one you want to use. And then we're going to write a little for loop to actually print the values one after the other. So I can simply say let integer I, let us have integer with data type and the variable name I, and then I can say for our I equal to 0, which is actually the first letter here, E, and then I can say that name, pass the name into I, name of I, then not equal to a null value, because the end of every string is a null value. So once you reach a null value, stop the iteration, and then what happens, I will increment I plus plus. So while you're doing this, what you're going to be printing is you're going to put char, and then you're going to print name of I. So what this means actually is the first time I is 0, so this I here represents 0, and which stands for E, to print E. But since it is not up to the values here, it will go back to increment I, and then here becomes 1, which will print N. So if I run the program now, it prints engine tech 0, 1. Okay, you can choose to print EN in line. So what you're simply going to do is immediately after you print the first one, okay, before you go back to the next iteration, let's have a line break. So come down to the next line, and then we're going to have something like this slash n new line, and then that's the end of the loop. So it's going to print in lines. You can see we have engine tech 0, 1 and the percentage. This is actually the manipulations of strings, arrays, and then pointers. So having this background knowledge, let's kickstart it with the task ahead of us. The first one here says that we should write a function that takes a pointer as an integer to an integer as a parameter and update the value it points to 98. Okay, what this simply means is that you should, let's take for instance, let me clear this off. Let's say that I have an integer value, let's say number, and it's equal to 10. Okay, then I'm expected to change this number when I'm printing. So let's say if I say printf, all right, percentage d, let's have new line, All right, the number is passed to it. And then if I run this program, I'm expected to see 10, just like what you've seen here. Now you're asked to write a program such that it will change this value to 98, okay, using pointers. And this is the prototype that's given. So let me get this prototype, right? And then I'm going to do it up here. You know, the same thing. So if I should say, I paste my prototype here, and then right here, let me just change here to reset alone because it's going to be too long for me to rest. Right, that stands for reset. Okay, so in here, I'm going to have this. Okay, so the only thing you have to do is that we're going to change this pointer, value of the pointer to 98 equal to 98. Okay, now when you come here, after you print 10, I'm going to revert the number. So I'm going to call that number reset number. All right. And then I'm going to pass here the address of none such that whatever value is in this address, because the n is pointing to number, right? This simply means you're pointing to the address of this number. So whatever value is placed inside this address of number will be changed to the new value here, 98. So hence, if I print again, printf, and the new line and number, I'm expected to have 98 because I have changed the value. So let's run that and see. Now, of course, you can see we have 98 right here. Okay. So, but what if I choose not to use this pointer here? Now, what I'm trying to do here is I'm sending the n represents an address of n. So you're trying to change the value of the address to 98, which is not going to print the value that you specify here. So let's see to that. Now you can see you have 10. You're still having 10 because the address of 10 is still, sorry, the address of n is still 10. You've not changed the value. The pointer here actually points to the address which this value is stored. So when you reference the pointer, the asterisk value, the asterisk, all right, you are trying to say when you get to the address of n, change the value to 98. So if I run this program, I'm going to have 98. I hope that is clear. So what I'm supposed to do right here is to have a prototype. Let me call it resets underscore 98.c. And in here, I'm going to take off this prototype here. I'm going to cut it off from here. And then I'm going to paste it right here. Let me use main.h as include main.h. And then I'm going to have my main.h file here, main.h. In the main.h, I'm going to have hash include stdio.h. Then I'm going to have this prototype. I'm going to copy this prototype and then paste it in the main.h. All right, and my main.c, I may choose to remove this and use only main.h. Okay, if I run this program, it's still going to give me the same result. All right, so this is what we're expected to do. Just this is what you're expected to do when you work with the main.h file. Okay, so let's go to the next step here. Write a function that swaps the value of two integers. Okay, let me get this prototype here. And then let me paste it here. So I'm going to call my own just swap, and I'm going to terminate here. Okay, so we're going to create another file called swapme.c. You can just use anything you like, it's the same thing. So in the swapme, the first thing I'll have is my include main.h file. And then I'm going to get the prototype here and paste it here. Okay, now let's see how to understand what this what this project means. The project is supposed to swap the value of A to B and then B to A. Let's try to understand the concept first, because that's what matters. Okay. Now, okay. Now, take for instance. Let's open this. Since it is void, we are not going to return anything. Now, take for instance, you have two hands, right? And you have two buckets, or let me say 10 liters of water in your two hands. Then you're asked to swap to that bucket of water. Note very well that there is no way you can swap at the same time without keeping one on the ground, and you were asked not to allow the water to touch the ground. All right. So what you can do in that respect, let me say hand 1 equal to 10 liters 1, and then hand 2, right, equal to, let me say 15 liters 2. Okay. Now you're asked to swap hand 1 to hand 2 and hand 2 to hand 1 respectively. Of course, you can't change them at the same time because your hands are occupied. So what you need to do is to call in a third party. So let me say friend, call in a friend and tell the friend, please help me to hold this bucket in hand 1. So I'm going to say 10 liters. 10 liters in hand 1. Okay. So when it wants to give this 10 liters to your friend, it simply means that your hand 1 is free. Can you see that? Your hand 1 is free at this moment. So you can now change your hand 2. Okay, hand 2, since you're free, give this water to hand 1 to hold. So you now see that your hand 2 is free also. Then you can now tell your friend, please give me that water I gave to you, and then you give it to what? Hand 2. That's how to swap. Okay. So what does that tell us? That simply analyze that we need 3 variables. The first 2 variables is actually what was given here, the pointer A and the pointer B, while the last variable is just a let me say a temporary variable that will hold one of the values for you. So let's try to implement that. So I'm going to have let's say an integer, let me call it temporary. All right, that's integer temporary file. So what we're going to do here is that the value that is present in A, give it to what? TMP. Right? Oh, sorry, that's not how it's written. You're supposed to start with TMP rather. TMP equals to asterisk A. So A, please give the value you have to temporary file. All right. Now at that moment, your A will now take the value of what? B. Okay, now B is actually free. So now what you got to do is that the B will now collect the value that was in TMP initially. So I've exchanged the concept, I've exchanged the values. Okay. I think that should give us what you're looking for. So let's see how that plays out. So right here, I'm going to have 2 variables. Num1, then I'm going to have integer num2 equals to 70. Okay. Now let's try to print that. So print printf percentage d, or let's say num1, it's equal to percentage d. That's for the first one. Then let's have a tab here, comma, and then num2 it's equal to percentage d. Let's have a new line here. So what I'm going to pass here is the num and then num2. Okay, let's extend it a little bit. All right, so let's print that further and see what happens. Okay, you can see that num1 it's 10 and then num2 is what? 70. So let's see how to swap that. For us to swap, we actually need to call this this function, the swap me function, which is swap. So I'm going to say in my main.c swap num1 and num2. Okay, When you're done swapping, then let's print again and see what will be the result. So let me just copy this one and paste it right here. So let's run that. Segmentation fault. Okay, we're supposed to pass the address of num1 and the address of num2. Okay, let's try that again. Now you can see that num1 equals to 10, num2 equals to 70, then num1 equals to 70, num2 equals to 10. It has been swapped. So that is the analogy of how to go about this task. I don't know if you understand, but I believe that you understand what I've just done there. If you don't, try to go through it again, try to replay the video. I'm sure you're going to get the intels of what I'll try to portray right there. Okay, so let's look at the next task here. It says write a function that returns the length of a string. The length of a string. Now, if you choose to use, let's say, okay, let's get the prototype first. Let's copy this and then put it in the prototype. Let's have this, and then I don't need this. I just need something that is short. S-length, let me call mine like that, S-length. So let's create a file for that. Length of a string, length of C. All right. So let's get the prototype here and then paste in there. Length of C. First, include main.h and then length of C. We don't need this, so let's take this off. So what does this mean? Now let's look at this. Let's look at something. Let's say I have my string, let me call it char, string of str, let's stand for my string, and then I'm gonna pass something like engine technology. Okay. Now, there is a predefined function to actually tell you the length of a string, and it's called string length. It's called strlen. Okay, and then you can put in the name str, which is the string variable declaration that you gave, and then I'm gonna print this out, printf. Of course, it's gonna return a numeric data type, so I'm gonna use %d. All right, let's have a new line, and then print the string length of str for us. Okay, so let's run this first and see what happens. Okay, you can't really run because this is a function that is found in the string header file. So I'm gonna add that, include string string.h. So let's run that. Okay, we need to close this. Okay, you can see we have 17. So let's count and see. E is 1, 2, 3, 4, 5. The space is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay. Now this function, the string length, is declared in the string.h header file. You are asked to write a program that will do the same thing, that will return the number of character in your string. Okay, so you're not supposed to use this string length, which is a default function, the function that is written to the program. You're asked to write your own function. That's what LX wants you to do. So what you'll simply do in the length is I'm going to be calling string length. When I call string length, just like what I've done here, it's going to print 17, but I'm not using this function here. So let's see how to do that. Now it's quite very simple. What you're going to do is to loop through. While you're looping, you're counting. Okay, I can simply do this. Integer I. Okay, I'm going to use I to count through. So for I equal to 0, okay, then is the value that is found here. Okay, the value that is found here is of I. That means if the value has not gotten to the end of the string, that's the null value, continue counting. not equal to null. Okay, this means that you should keep on counting the values until you get to the null position. Once you get to the null, don't count again. So increment your I plus plus. Okay, so I can terminate that, and then what will I do? I'll return I. Okay, let me just take this down. So let's see what happens to my main file. So let's go to the main and then change this to S. What did I call it? S length. So let's call this S length. And then let's run the program. So you can see we have 17. The same thing with the string length. So what does that simply mean? It tells us that we've been able to write a program that loops through while looping your counting, because the I is actually counting 0, 1, 2, 3, 4. So it's counting just like that. And then we have 17 at the end of the day. That's how to tackle that situation or that program that was given to you. The next one here is write a function that prints a string followed by a new line to the standard output. I'm sure that one is quite easy. You can do that. So let's move to the next task. Write a function that prints a string in reverse followed by a new line. Okay. Print a string in reverse followed by a new line. Okay, so how is that possible? Let's see how to do that. Now, look at this. We have engine technology here. I'm going to use the same thing to write the program. We have engine technology. And if I say print str, let me just use str here. Percentage s for string, then you're going to print str. Okay, so if I run this, you can see engine technology. Let's have new line. You can see engine technology, right? Now you are asked to write a program that reverses this string. Instead of starting from E, start from Y, G, O, like that till it gets to the beginning. Now what comes to your mind is this. Look at this. If you look at this program you wrote on the string length, it has a similarity. What is the similarity? The similarity is that the characters count from the first character. 0E, start from the first character, 1, 2, it counts like that till the end. Okay, so at the end we have 17. The 17 represents Y, right? Okay, the 17 represents Y. So that means if I should start from 17 to count down, it will start printing from Y. Let's see what I mean by that. Let's look at what I mean by that. So let me try to print a character instead of a string. And I'm gonna pass. If I pass something like, let's say 17, which was the last value, and then run the program, you can see okay, it's empty. Let's say I passed 16. Okay, you can see we have Y. So why was 17 not printing? That's because it is counting the index. All right, the first index is 0, 1, 2. So 17 elements in an array will resolve to 16 indexes. So that's why I'm having Y here. So if I try to pass 15 here, I'm going to have what? I'm going to have G, which you've seen that. So that means if it counts down reverse, I'm going to have that value being printed using character data type. So the question is, how do you get the number of elements that has been counted? Of course, we know how to do that with the length, which we've just done previously. So now this is going to be needed. So I can just get this and copy this to, did we declare the function? No. So let's get the prototype. Let's get the prototype here, and let's have it here, and then I'm going to call it reverse. Don't need long story. Okay, so let's get this to write the program for that. And I'm going to call this reverse.c hash include main.h, and this is the prototype. So I'm going to have this written here. So I'm gonna paste this one since it has similarities. So let's get this copied and then paste it here. All right. So why am I doing this? I want to know the number of characters we have in the array. All right. I want to know the number of characters we have in the string. So this is gonna be counting, and if it counts, I'm gonna have 17, right? So after that, the next thing I want to do is to actually print in reverse. Okay. So I'm gonna have something like, let's say, another variable here called j, and then for this time around, I'm gonna say for j equal to I. Okay. What does that mean? J is not going to start from 0, but it's going to start from the last value of I, which is actually 17. So j equals to I. Now, I'm going to pass j greater than or equal to 0. So what that means is that you're going to be counting down till j gets to 0, all right? Then j minus minus. At this time, you're decrementing, you're not incrementing. So while you're decrementing, what you'll be doing is to be printing the characters. So print f and then the character %c. All right. And then what you're going to be printing is s in j. Okay. So what does that mean? For the first time, if actually j is 10, it's going to look through and find out the character that takes the 10th position and then print. So we're going to call the reverse in our main function. So in here, I'm going to print str using the string. Then after that, I'm going to call the reverse string for me. So when you reverse the string, try to print it for me according to what was given. So let's run this and see what happens. Okay, so you can see engine technology, and then you have the YGO technology in reverse engine. That's just how to write that program, and then you can maybe try to toggle it and then have your own concept to have something meaningful. There is no new line here, so you can apply that. And where can you apply that is to apply it right here. Okay, you can put the /n here. Let's run that again. No, oh, sorry, we can't apply it here. Sorry, it's gonna print the new line per time. So what you need to do is after this, you can simply add maybe butcher, and then let's have a new line here, and then let's run that again. Yeah, you can see we have our program running correctly. Okay. The next one here says reverse string is almost the same thing, just a little different. You can see this, my school reverse, and then you can see this, this value given to us. I don't fear computers. I fear the lack of them. I do not fear computers. If you look at this, the reverse of this, but just look closely. There is just a little difference I want to spot out. I'm not going to do that now. Okay, let's go to the next one here. It says write a function that prints every other character of a string, starting with the first character followed by a new line. Then we look at the sample here. You can see we have 0, 2, 4, 6, 8. Now this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. What does that tell you? It simply means that they're skipping the printing per time. Now let's take, for instance, let me just run something on the main.c to illustrate that. Or let's just copy this to avoid wasting much time. Let's just get this, and let's just represent that with this. So okay, now we are supposed to let me remove this since I'm not going to use the same thing here. Now we want to print 0, 2 according to what is given here, 0, 2, 4, 6, 8, 0, 2, 4, 6, 8. So the first thing what you need to do is to look through for integer I equal to 0. Okay, for the first index we have 0, and then str of I, okay, not equal to null. You can use the other one we normally use, still the same thing, and then your I will increment I plus plus, okay. So if we probably try to print this, let's see what happens. Print f, a percentage c is a character, so we are gonna have the str index. So we're gonna have 0 to 9 right now. You can see we have 0 to 9, but we don't want to print 1, we don't want to print 3, we don't want to print 5 like that. So what you need to do is to print in 2 places. All right, so you just change this place to plus equals to 2. That means increment the values in 2 difference. So the first time is going to print 0 index, second time is going to print the third index, fourth time is going to print the fifth index. It continues like that till it gets to the end of the string. So if you run this, you can see we have 0, 2, 4, 6, 8. All right, so that is that about that very task. Okay, here you're asked to write a function that prints half of a string followed by a new line. Okay, now we have the same value 0, 1, 2, 3, 4, 5, 7, 8, 9, and then you're asked to print the half starting from 5, 6, 7, 8, 9. Okay, how can you manipulate that? Okay, let's see to that. I'm gonna write this as a function. So let's say let me create a new file called print half.c. All right, and then let's get the prototype. Let's copy these and then let's hash include main.h, and then let's paste it here. Okay, so I'm gonna call mine half. Don't need long stories. Let me copy this to my main.h, terminate that. So let me get back to my where is it, print half. Okay, now the first thing you need to do is to know the length of your string. So I'm gonna come here to the length of my string and copy this and then paste it here. Okay, so this will determine the length of my string. So I can simply add str here to complete this parameter that was given. Okay, so after you count these strings, you need to divide it into 2 equal parts. So I'm gonna call this half. So my half will be equal to I divided by 2. Okay, now what does that mean? Let's assume you had 10. So it's going to divide into 2. I'm going to have 5. So my printing now is going to start from that 5th one which has been divided. So the next thing I'll do is to loop through. So I'm going to have another variable here called j. So for j will be equal to half. You're not going to start from 0, but rather you're going to start from half wherever the value is placed. Okay, then then the str will continue from there to count further, not equal to null. Okay, then j will increment j plus plus. All right, and then at the end of it all, you're going to print. You're going to print a percentage c. You're printing characters str of j. Okay, and okay, so let's call this function half and see what happens to our main file. So let's remove this and then call the function half. Is that what I called it? Let me check. Print half. Okay, yeah, half. So call the function half and give it str. Okay, so let's see if it's gonna print from 5 down. Let's run the program. Okay, you can see we have 5, 6, 7, 8, 9, which is equivalent to what was required here. So that's how to manipulate that very problem. First, count to know the number of characters you have in the array. Then after counting, you divide it into two. Then wherever your division stops, start from there to print. Okay. The next one here is write a function that prints n elements of an array of integers followed by a new line. The prototype is this. Okay, let's say we have, this one is quite simple, so I'm going to explain for you to do something on it. Now, let's say you have this element here, my main file. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, I just need to print the first, let's say 3 elements. So what I'm gonna do is I'm gonna say something like print, assuming that was a function you wrote, print str, but don't print everything, just print the first 7 elements. That's what the n means. So it's gonna take the first 7 elements and print, leaving behind the rest. I hope that's pretty simple. Okay, so let's look at the last one here. It says write a function that copies the string pointer to str, including terminating null byte to the buffer pointer to the desk. All right, this is the prototype given, but I'm not going to use this. Let me use something different from this. So I want you to actually try to understand the code in different dimensions. Okay, so I'm going to call my prototype, let me just call it copy.c. And then, okay, in here, I'm going to have hash include main.h. Then my function is going to be like void. I'm going to call the cp, that's copy. And then I need just, let's say, a character pointing to an array. So I'm going to have this. Okay, first, before I go into this solution, let's actually have our prototype. So let's get this to our prototype and then add it here. Okay. Now, in my main.c, let me take this off and then let's assume. Okay, let's assume I have these values here. Let me take this one off. Okay, so I'm gonna copy this from the pointer given. I'm gonna copy that from the pointer C to another array. So let's say I can create a pointer. First, I'm gonna have a character, and let's say I can make this, let's say 50 or 100. The best way to utilize this is to use malloc, but since you're not up to that stage yet, let's try to use a defined memory allocation. So let me create a pointer, and then the pointer is going to be a character that I type pointing to, let me call it new. Okay, and then the new is going to point to the variable called old. So new will be equal to old. Okay, all right. So now what we're going to do is when you get the characters given from the main.c, which is this str, you're going to copy this same thing to the new memory allocation, which is new. So what you got to do is to loop around for, let's say, integer I equal to 0. And then, of course, the value of c will be counted, c of I should not be equal to null. Right? And then I plus plus, increment it. So at this stage, what you got to do is that your new of I will be equal to your old of I. Okay. So what this simply means is that all the values that will be present, sorry, not old, is going to be C, not old, sorry. So all the variables, all the element that is present in the C pointer will be copied to the new memory allocation, which is a new. Then when you're done with that, you simply print the new. So let's have the new printed, print F, and then percentage S, and then new. All right, so let's see what happens to the code now. And let's run this. Okay, we got some error here. We need to next this, and let's see where the error comes from. We've not line 17 in the main.h. Okay, so we go to main.h, then line 9, sorry, terminate this. And then the second one says in main.h2, we have to terminate this. Second, still the same thing. Here is the copy.c line 1, copy.c. So let's try to correct this main.h. Let me write it again. Hash include main.h, and let's just run and see what happens next. Okay, I think the error is corrected, but it's not printing. So let's see where that is coming from. Okay, here looks pretty good. So let's check our main.c. All right, we did not actually call the function. So the function is cp and then the character. So we just got to call our function here. And we're supposed to pass in the character. You're supposed to pass in the variable that holds the character. So we need to pass in str here. Okay, I think that's all. So let's run that again. Okay, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's it's printing from the new. Okay, and then you can also choose to probably print that of C. All right, so if I remove this and print C, and you can see we still have the 0 to 9. So I can choose to print the two of them at the same time. So I can choose to say printf, and then the same percentage %a/n, and I'm gonna pass the new here. All right, and semicolon. All right. So if I print this, I'm supposed to have the two content. All right, so 0 to 9, 0 to 9, I have two content printed. I think that's pretty cool. So that's how to copy. You can now use this idea to manipulate and solve the task that's expected of you. So I think that's the end for the mandatory task. This is advanced. So thank you for having me right here. Your host, Engine Tech. See you in the next video. Thank you for subscribing to my channel. I love you guys. Bye for now.